So let's try a word problem. So an important application of exponential equations is Newton's law of cooling. This law states that for a cooling substance with initial temperature T sub O or not, the temperature T after T minutes can be modeled by this equation, where R is the surrounding temperature and R is the cooling rate of the substance. So you're cooking an Ethiopian stew, alicha. When you take it off the stove, its temperature is 212 degrees Fahrenheit. The room temperature is 70 degrees Fahrenheit, and the cooling rate of the stew is R equals 0.046. We want to know how long will it take to cool the stew to a serving temperature of 100 degrees Fahrenheit. So let's write down what we know. The temperature that we want to end with is 100 degrees, a serving temperature. The initial temperature is 212 degrees, T naught. The room temperature, I call it TR, room temperature is 70 degrees Fahrenheit, and the rate is 0.046. So what we're going to do is plug in what we know. We have 100 equals 212 minus 70, and then e to the negative 0.046 times time plus TR, the room temperature, which is 70 degrees. So we're trying to solve for time here, so that is our goal. So what we want to do first is let's go ahead and subtract 70 from both sides. So now we have 30 equals, let's go ahead and subtract 212 minus 70 to simplify that a little bit. That's 142. Then we have e to the negative 0.046 times time. So now we're still trying to solve for t, so let's divide by 142 from both sides. And then so what we find when you do this in your calculator, you get 0.2113 equals e to the negative 0.046 t. Now in order to cancel out this e, we want to take the natural log of both sides. So take the natural log of both sides, and that'll cancel this out here. And so then we can evaluate, well, let's see what we have now. So we have natural log of 0.2113 equals negative 0.046 t. And then what we want to do is divide by this negative 0.046, negative 0.046. And then so now, when you plug this in the calculator, you will get your time. So you press natural log, or if you're in the gray calculator, plug in 0.2113, and then natural log, sorry, not divided by, 0.2113, natural log, and then divided by the negative 0.046. What you will find is that it's approximately 33.8. So what this means is it will take approximately 34 minutes to cool the stew to the serving temperature, to cool stew to serving temperature of 100 degrees. So good to know, right? So if you're cooking it and 212 is when it's boiling, you know it'll take about 34 minutes to cool. So try this same example, but you're going to say how long will it take to cool the stew to 100 degrees when the room temperature is 75 degrees. So the room temperature is a little bit warmer, so it should take a little bit longer. So try this out. So if you tried it out and plugged it in, you would find that it is approximately 36.98 minutes or about 37 minutes to cool the stew to a serving temperature.